Hello everyone, engineering statistics and linear algebra. We have started second module and in first video we have discussed multiple random variables, bivariate cumulative distribution function and their properties, bivariate probability density function and their properties, what you mean by possible and impossible events, calculation of a single random variable PDF using bivariate PDF, what you mean by independence. And in second video we have solved problems on bivariate CDF and PDF. Today we do discuss difference between two bivariate CDFs and it is denoted as a DP. Today's discussion emphasizes on the interpretation of cumulative distribution function, that is understanding of a CDF. For this, one assumption should be made here, that is a probability of bivariate observations, also called as a CDF, occurring in a quarter plane to the left of and below the points xy. CDF is defined as, and it is a probability of a bivariate observations. A size of this CDF is a quarter plane. It is located at left of and below the point xy. This assumption should be made here. Consider a xy plane. It consists of four quarters, 1, 2, 3, 4. The size of CDF is 1 quarter, somewhere, any one of the quarter here. And where it is located, its location is given with a statement left of and below the point xy. It is a point xy, left of means this complete area, and below the point, then this is what a CDF. For this given statement, this is an assumption here. This is a CDF, that is a probability of bivariate observations. It is located at left of and below the point xy. Here let us calculate two CDFs here. One CDF is located at a point xy, another one is the point x plus dx and y plus dy. This is the graph for that. Same graph, but a small distances dx and dy are added to the points x and y respectively, so that area of this plane is increased with the value dx and dy. Then the difference between these two bivariate CDFs is the probability dp, which must be non-negative. PDF of this graph is denoted as f of xy, x comma y, and it is a probability of intersection of two random variables x and y. How to denote this CDF? It can be denoted as f of xy with independent variables x plus dx and y plus dy. It can be defined as probability of intersection of x and y. So x is x plus dx and y is y plus dy. This complete explanation let us understand using some graphs here. Alright, so let us consider one plane xy and the point xy. CDF is a quarter plane. It is located left of and below the point xy. CDF of this is given by the following equation. Okay, let us consider the one more plane xy. This point is existed located at x plus dx and y plus dy. Small distances dx and dy are added to the points xy. As a result, the position of this p is increased here. It is shifted above, and CDF for this plane is existed again left of and below this point. Yes, this is the. Then CDF for this plane is denoted as this one, and it can be defined as a probability of intersection of two random variables x and y. We are in need of a difference between these two planes. Difference between these two planes is given as larger CDF that should be subtracted with a smaller area. Okay, if these two are subtracted, then what will be the result? Only this shaded area. Difference between these two, as a result, only this blue area will be remaining. As a result, difference between these two areas at a point xy and at a point x plus dx and y plus dy, as a result, only this area is existed after subtraction. This area is called as here the difference area dp. It can be calculated as a difference area dp. It is the difference between two bivariate CDFs, and it can be defined as the difference between this CDF and this CDF. Okay, so this is how to calculate difference area DDF. In next video, we do discuss problems on this concept, and like, share, comment on the videos, and subscribe the channel. If you have any doubts, then feel free to ask me, and make this online coaching so interactive. Thank you.